So these notes are going to be what we're going to fill in before each class time so that we can get through the basics outside of class time and have more time to do more interesting things during class. So chapter 1 is all about equations and inequalities, and 1.1 is linear equations, and hopefully this is going to just totally seem like review, as in objective 1 we solve a linear equation. But one of the things that I care about is that you know what a linear equation is, and that if I write a test problem that says write and solve a linear equation, you could do that. So the second objective is going to be to solve equations that lead to linear equations. So they might start out looking like something else. And you can find these objectives in your textbook if my writing's too messy for you to read. Sorry, it's hard to write with this tool that I have. And then the third objective is to solve problems that can be modeled by linear equations. And it turns out there's lots of real-world situations that pretty closely fit a linear model. So when you write f of x equals mx plus b, that could be thought of as a linear model, that it's modeling something real. So we're going to go quickly through some procedures that result in equivalent equations. So you can, of course, interchange the two sides of an equation. 3 equals x is exactly the same equation as x equals 3. That usually seems really obvious to most of us by now. You can simplify the sides of the equation by combining like terms. So you're always going to want to combine like terms when you can, because your answer is not simplified unless you have. So you're going to combine like terms and eliminate, so eliminating parentheses. So remember that means to use the distributive property usually. In this case, there isn't anything to distribute even, so the parentheses can just be removed because they're not really serving any purpose. So then the third thing we can do is add or subtract the same expression on both sides of the equation. This is called the additive property of equality, the APE. And I want you to state this when you're using it. So off on the side of your work you'll say, I'm using the additive property of equality, and just note that that's why you can do the step that you're doing. So this is where we can, on both sides of this equation right here, we can add 5 to both sides, and the reason is because of the additive property of equality. So make sure you know what an expression is. If it doesn't have an equal sign, it's an expression. So 4x plus 5 is an expression. 1 over x is an expression. Okay, the fourth thing we can do is multiply or divide both sides of the equation by anything. I think we better be more specific. By the same non-zero expression. So you have to be really careful when you're doing this, that whatever you're multiplying or dividing by is not 0. So if you were going to multiply both sides by the quantity x minus 1, you better specify that x minus 1 doesn't equal 0, which means the same thing as x doesn't equal 1. So you have to specify that to make sure that you're not multiplying by 0, because as you and I both know, if you multiply both sides of the equation by 0, you kind of just destroyed it and made it 0 equals 0, and you're not going to be able to solve it. So that word non-zero is actually very important. So this is our multiplicative property of equality, or MPE. So if you ever multiply both sides of an equation by the same thing, you're going to say over on the side, okay, I'm using the multiplicative property of equality. Now if one side of the equation is 0, and the other side can be factored, then we can use the zero product property And you're going to see that this one comes up over and over and over, the zero product property, and set each factor equal to 0. So this is because if we have two things multiplied together and they equal 0, then that says either A equals 0 or A equals 0 or B equals 0. That's the only way that you can multiply two numbers together and get 0. Well, this is true for any number of things multiplied together. So if we multiply 4 things together, then we know either A is 0 or B is 0, etc. So this is called the zero product property, and again, I'm going to ask you to note that. If that's the property that you're using, then say that I'm using the zero product property. So here's a simple linear equation to solve. You're going to add 7 to both sides by the additive property of equality. So you're going to get 4x equals 20. Divide both sides by 4 by the multiplicative property of equality, and 4 doesn't equal 0, so we're good there. So then we get that x equals 5, and that's our answer. And I'm a big fan of checking answers, so this one's very simple. Hopefully you can do it in your head, but you should at least check and go, yep, that works. So objective 1 is solve a linear equation. And I have a purpose for having you write the objectives. The objectives are what you should know by the time we're finished with this section. So it's a good practice to go through and say, do I know how to solve a linear equation? Do I know what a linear equation is when we get to the end of this section? So a definition that we need is that a linear equation in one variable is an equation equivalent in form to ax plus b equals 0, where a and b are real numbers, and a needs to not equal 0. Because if a is 0, we have a pretty boring equation. It just says b equals 0. So there's one variable. Here is the one variable. The a and the b are constant, not variable. So we're using letters in two different ways here. The x is the thing that will vary during the problem. The a and the b will be fixed for a particular problem, but they might be different in different problems. So sometimes this is called a first degree equation, because the highest power you see on the variable is that invisible 1, right? If we need a variable, an exponent, we don't see 1, it's a 1. So your strategy, of course, is to isolate the variable. This is only the strategy for a linear equation in one variable. You need to have different strategies for different kinds of equations. That's why it's so important to be able to identify the problem that you're looking at. Say, oh, this is a linear equation in one variable, so I know I need to isolate the variable. Well, here I see that I have fractions. I really don't like fractions, so I am a big fan of eliminating the fractions by looking for, let's see, the least common multiple of 3 and 4. That's going to be, doesn't look like to have anything in common, so it's going to be 12. So if I multiply both sides of the equation by 12, by the multiplicative property of equality, because 12 isn't 0, so we're safe doing that. Remember that you need to distribute that to each term. I have 2 terms on the left, only 1 term on the right. So I'll have 12 times a third times x minus 1 minus 36 equals, the associative property says I can combine the 12 times the 1/4 to get 3. Before I distribute, I can do that multiplication in any order with 3 things. So 12 times 1/3, again, I can associate these together and get a 4 times the x minus 1 minus 36. And I'm doing one step at a time on both sides. So now I need to eliminate parentheses by distributing. So this hopefully seems very familiar. Now I'm going to combine like terms. Then I'm going to use the additive property of equality to add 40 to both sides. It doesn't matter which side you end up with all the x's on. That's up to you. I'm going to choose to have the x's on the left and everything that isn't an x on the right. And then I'm going to subtract 9x from both sides. Get negative 5x equals 46. And nobody told you these would come out pretty. We'll check our answer to make sure, but we'll divide both sides by negative 5, and x is negative 46/5. So let me just make sure I like my answer. Oh, I think that's right. So let's see, if we have x is negative 46/5, I'm going to plug it back into the original equation. I have 1/3 times negative 46/5 minus 1 minus 3. And I want to know, this is a question mark, if that equals 1/4 times 3 times negative 46/5 plus 2. So it looks like I have negative 46/15 minus 1/3 minus 3. And I want to know if that equals negative 138 over 20 plus 1/2. This is kind of messy, but we can do this. Minus 46/15 minus 1/3 times 5 over 5 minus 3 times 15 over 15. Negative 138 over 20 plus 1/2 times 10 over 10. So it looks like we have negative 46 minus 5 minus 45 over 15. And we want to know if that equals negative 138 plus 10 over 20. So it looks like we have negative 96/15. And we want to know if that equals negative 128/20. So let's see, if I reduce on this, I'm going to get negative 64/10, which is negative 32/5. If I reduce on this side, I'm going to get negative 32/5. So it worked. It was a funky answer, but it worked. So expect to do problems of that difficulty level. They're not tough. Objective 2 is solve equations that lead to linear equations. And we're going to do these examples in class together, so they're a little more complex. But probably you already know you need to FOIL the left-hand side, then FOIL the right-hand side, then combine in like terms, get all the x's on one side, isolate the variable. So we'll talk about the rational equations in class together. And then objective 3 is the solving problems. So solve problems that can be modeled by linear equations. And we'll do this word problem together in class. And I want you to write down the instructions for all word problems, which are going to be define variables clearly. I'm a real stickler about this. So I want a very detailed description, like x equals milligrams of cholesterol in eggs. Something very specific. Okay, so you define your variables clearly, write algebra equations, and solve them. And then you need to write your answer in a complete sentence. So I say this once at the beginning because I want you to remember it for the entire semester and for the rest of your math career, in fact. Define your variables clearly, write algebra equations and solve them, and then write your answer in a complete sentence. So we're going to work on this problem together, and then we'll go through this summary really quickly to make sure we're all together moving forward. And that's going to be what we do in class tomorrow. So look forward to seeing you then.